So far, we've learned that while real walking is the best option for a natural and comfortable experience, it's not always possible due to physical space limitations. This means we need alternative options for locomotion in VR. In the previous video, we learned that walking in place, while a valiant attempt, still has a pretty good risk of motion sickness. Of all the alternative options out there as of now, teleportation is going to offer the most comfortable experience for the largest audience. Teleportation, just like in Sci-Fi, provides instantaneous transport from one location to another. However, as with all alternatives to real walking, it does have its pros and cons. There's less physical space needed, and you can travel long distances instantaneously. Among the various types of virtual locomotion available, teleportation is the least likely to cause motion sickness when implemented correctly. However, it's less immersive than natural walking. It can cause disorientation or sickness if your head rotation shifts during transport from one location to another. People can overshoot the target location, resulting in them having to try multiple times to get into the right position. And when teleportation areas aren't set up well, people can accidentally teleport into a wall or another virtual object, which breaks the sense of presence and immersion.
If you would like to continue getting free content like this, be sure to like this video, share it with your friends, and subscribe to the YouTube channel. And if you have a moment, comment in the videos. That will really help me know what's important to you as I create more content.
There are two major types of teleportation, blink and dash. The blink variation fades out and back in, much like an eye blink, only slower, as you move from one location to the next. This eliminates any sense of motion as you move around the world, thus removing the risk of motion sickness from movement. The dash variation teleports you instantly while still letting you see rapid motion in your periphery. And remember, motion in your periphery is one of the major causes of motion sickness. So if you're using this variation with the purpose of reducing motion sickness, it won't work as well as the blink variation. The most appealing use case for this type of locomotion is for first-person shooters and other VR action games. If you're using the dash variation, make sure there's a more obvious blur effect to reduce the risk of sickness from motion in the periphery. With either of these variations, if there's not a sufficient delay time set up between teleportation action, if you move rapidly in succession, it will still give you the perception of motion, which will then bring back that risk of motion sickness. As for my recommendations, make sure you're including a sufficient time delay between movement actions when you're implementing teleportation in your project. Ensure there's a target reticle included on your teleportation curve to confirm the selection of the target location so people know where they're going to land upon teleportation. Use wayfinding such as a lit path or waypoints to help people know which way to go. Be intentional in the creation of your teleportation areas in order to prevent people from accidentally teleporting into walls or other objects. Preserve the person's current head rotation and blur the scene or blink between locations to help reduce the risk of motion sickness. If you're changing the direction the person is facing at the target location, add a visual cue to let them know which way they'll be facing when they arrive, such as an NPC facing that direction or some sort of signage. In some cases, it may make sense to use predefined target locations or teleportation pads to prevent people from having to teleport multiple times to get in the right position, such as when there's sparse target locations in a very large world space. If you're using predefined teleportation pads, use lit waypoints to direct people and snap the reticle to the waypoint with magnetism or assume intent to get them to the correct location. Upon teleportation to a predefined target location, place the person in the optimal position within that target location. You can see examples of how other people have solved this problem by checking out the growing pattern library on my website. The link is in the show notes.
I'd like to say thank you to all of my Patreon supporters. It really does mean a lot and makes a big difference. Creating this content takes a lot of time, money, and effort, so your support helps me to continue creating educational content like this. Becoming a patron also gives you access to our private Discord server, gives you early access to these videos, and gives you access to exclusive content not available anywhere else. If you'd like to become a patron, check out the link tree in the show notes.